Good morning, everyone. This is your science class. Let's talk about Quarter 3, Module 1, Part 2, Science 7, entitled Let's Do the Motion. This is Sir Topper, your Science 7 teacher. Before we proceed, let us pray. In the name of the Father, the Son, the Holy Spirit. Amen. Dear Lord, enable me to teach with wisdom, for I help to shape the mind. Equip me to teach with truth, for I help shape the conscience. Encourage me to teach with vision, for I help to shape the future. Empower me to teach with love, for I help to shape the world. Father, the Son, the Holy Spirit. Amen. Good morning, everyone. So for today, we're going to tackle about Lesson 2 of Module 1, Quarter 3 of Science 7, entitled Speed, Velocity, and Acceleration. We're going to differentiate. So what I need to know. Hello, how are you? Have you observed the road signs near your school zone? Have you seen signs like school zone and speed limit 20 kilometer per hour? What do these signs mean? In Lesson 1 of this module, you were able to describe the motion of an object in terms of distance and displacement. Distance and displacement answers the question, how far did the object travel? After determining how far the object moves. The next question in describing motion will be, how fast did object move? So what I need to know. This lesson will help you understand how fast an object moves quantitatively through its speed, velocity, and acceleration. After going through this lesson, you are expected to first, define speed, velocity, and acceleration. 2. Differentiate instantaneous speed and constant speed. And last, solve problems involving speed and velocity. What I know. Actually, this is our module review. Direction. Choose the best answer from the given choices. Key in your answer in our class point app. And our class code is 12452. Number 1 question. Number 1. Which of the following is defined as a displacement covered per unit time? A. Is it acceleration? B. Displacement. C. Speed. D. Velocity. Okay, let's reveal the answer. The correct answer for number 1 is letter D. Velocity. Let's move on with question number 2. Which of the following is a unit of speed? A. Meter. B. Second. C. Meters per second. D. Meter per second per second. Okay, the correct answer is letter C. Meter per second. Number 3 question. What is shown when you look at the speedometer in a moving car? A. Average speed. B. Average acceleration. C. Instantaneous speed. D. Instantaneous acceleration. Very good. That is C. Instantaneous speed. Let's have number 4 question. Which of the following is defined as the change of velocity per unit time? A. Acceleration. B. Displacement. C. Distance. D. Velocity. Very well said. That is correct. It's letter A. Acceleration. Number 5 question. Which of the following statements refers to velocity? 1. Boy walks 30 meters east. 2. Car runs 40 meters per second west. 3. Ball rolls 10 meters per second north. Or 4. Air moves 100 kilometers per hour. Very good. That is letter C. 2 and 3 only. Car runs 40 meters per second west and ball rolls 10 meters per second north. Very good. Let's move on with question number 6. So with this, you're given data were obtained from a 200-meter dash competition with female athletes 1, 2, 3, 4. Recorded times 26.5 seconds, 26.1, 25.3 seconds, 26.7 seconds. We have male athlete 1, 2, 3, 4. Recorded time 22.4 second, 21.9 second, 23.0 second, 22.6 seconds respectively. The question is, which of the following statements is or are true? Refer to that data at the left. 1. The female athletes are as fast as the male athletes. 2. The male athletes are faster than the female athletes. 3. The fastest athlete has recorded time of 26.7 seconds. 4. Compared to the speed of the fastest male athlete, the average speed of the fastest female athlete is slightly less. Is it A, 2 and 4 only, 3 and 4 only for letter B, C, 1, 2 and 3 only, and D, 2, 3 and 4 only? So that is correct. It's letter A, 2 and 4 only. The male athletes are faster than the female athletes. Compared to the speed of the fastest male athletes, the average speed of the fastest female athletes is slightly less. Congratulations. Let's move on with number 7 question. How do you compute for the average speed of each athlete? Is it A, divide the recorded time of travel by 200 meters? B, divide 200 meters by the recorded time of travel? C, multiply 200 meters by the recorded time of travel? Or D, divide 200 meters by twice the recorded time of travel? That's correct. It's letter B, divide 200 meters by the recorded time of travel. Congratulations. Let's have number 8. Which of the following statements is not true about the object moving with constant speed? A, the object is not accelerating. B, the speed of the object is equal to 0. C, the distance traveled by the object increases uniformly. Or D, the speed of the object remains the same all throughout the travel. Very good. That is letter B. The speed of the object is equal to 0. Let's move on with number 9 question. What is the speed of a moving vehicle in going upward in an inclined road? A, increases. B, decreases. C, the same. Or D, both increasing and decreasing. Very good. That is correct. It's letter B, decreases. Let's move on with question number 10. A moving jeepney is approaching an intersection. What should a responsible driver do? Concentrate on the box. Number 1, continue driving. 2, increase the speed. 3, decrease the speed. 4, step the brake immediately. Is it A, 1 only? B, 3 only? C, 2 and 3 only? Or D, 3 and 4 only? Okay, the correct answer for number 10 is the letter B. Decrease the speed. Okay, let's move on with number 11 question. Who among the runners had the greatest speed? To answer this question, let us consider the given table. Runners W, X, Y, Z with distance. For W, we have 70 meters. For X, 80 meters, Y, 95 meters, and Z, 105 meters. And for the time for W is 10 seconds, X, 10 seconds, Y, 10 seconds, Z, 10 seconds. Okay, let's go back. Who among the runners had the greatest speed? Is it A, runner W, B, runner X, C, runner Y, or D, runner Z? The correct answer is letter D. It is runner Z. Okay? Number 12 question. Which of the following situation or situations exhibits accelerated motion? 1. A car travels 10 km in 1 hour. 2. A boy on his bike moves around a curve with a constant speed of 6 km per hour. 3. A girl initially running around 2 km per hour suddenly stops because of a truck. Or 4. A man initially running at 7 km per hour due east moves west at the same speed of 7 km per hour. A. 1 and 3. B. 1, 2, and 3. C. 2, 3, and 4. And D. 1, 2, 3, and 4. Very good. The correct answer here is letter C. 2, 3, and 4. Okay, so let's move on with question number 13. Given the table below, which of the following statements about the learner's speeds is true? Learners are Rhea, with a distance traveled of 40 meters in time 8 seconds. April, distance traveled 20 meters, time for 5 seconds. Stella, distance traveled 60 meters and time is 12 seconds. Is it A? Stella is greater than Rhea, which is greater than April. Rhea is equal to Stella and less than to April. Or letter C, April is less than Stella. Stella is equal to Rhea. Letter D, April is less than Rhea, but Rhea is greater than Stella. Okay, the correct answer for number 13 is letter C. April is less than Stella, but Stella is equal to Rhea. Let's move on with question number 14. Edmar conducted an experiment on speed using his toy car. He listed all the data he gathered in the table below. Upon analyzing his data, he concluded that toy car C is the fastest among the four. Do you think his conclusion is correct? Okay, this is the table. Toy car A, B, C, D with a distance in centimeters. They are all 100, but the times differ from each other. A is 10 seconds, B is 15, C is 20, and D is 18. Okay, is it A? Yes, because its speed is 20 meters per second. B. Yes, because it has the greatest time recorded. C. No, because all the toy cars travel the same distance. Or letter D. No, because the fastest toy car is the one that took the least time. Very good. The correct answer here is letter D. No, because the fastest toy car is the one that took the least time. Okay, so with this review, let's have the last question. Lei was asked by her teacher how to solve the speed of an object. She said that to solve for the speed of an object, one must multiply the distance traveled by the recorded time of travel. Do you think her process is correct? A. Yes, because multiplication is the way to solve for speed. B. Yes, because she had all the needed data like distance and time. C. No, because in solving for speed, one must divide the distance traveled by the recorded time of travel. Or D. No, because in solving for speed, one must add the recorded time and the distance traveled. Okay? With question number 15 as our review quiz, correct answer is letter C. No, because in solving for speed, one must divide the distance traveled by the recorded time of travel. Very good. So let's continue. What's in? Hello, in the previous lesson, you have learned that objects can be described by measuring and identifying certain properties such as distance and direction. You have also learned that motion involves a change in the position and passage of time. Hence, the motion of objects can also be described by measuring the properties of distance and time. Combining these measurements describe the three quantities of motion. I repeat, describe the three quantities of motion, such as speed, velocity, and acceleration. So we are going to discuss this one by one. Before that, let's have this one. Activity 1, distance and displacement. So this is just a review. You walked 40 meters east from your house to school. However, you forgot to bring your books, so you decided to return home. On your way back home, 20 meters due west, you meet your brother carrying the books you forgot. After receiving the books, you turned east and walked an additional distance of 30 meters to reach your school. What is the total distance that you've walked? What is your total displacement? When you arrived at school, you found out that the classes that for that day were suspended. You went back home through the same path. What is the total distance you walked in going to school and returning home? And number 4, what is your total displacement? So let's have the answer. For number 1, what is the total distance that you walked? It is 50 meters. What is your total displacement? We have 50 meters due east. Number 3, what is the total distance you walked in going to school and returning home? Just add the 50 meters that by 50 meters. So we have 100 meters. How about what is your total displacement? So you return to your original position, so your total displacement is 0. Let's have activity 2, fun walk. So this is an activity for a group. So I'm going to give you this for your assignment. Okay? So here are the guide questions. So let's proceed. What is it? Let's have what is speed? A description of how fast or slow an object moves is its speed. It is the rate at which an object changes its location. Like distance, speed is a scalar quantity. It has only magnitude or size, but there is no direction. The average speed is the distance traveled divided by the time it takes to travel the distance. And the SI unit of the speed is meters per second, or in symbol meter per s or m per s. But other units of speed such as kilometers per hour or km over h, or miles per hour or mph are sometimes used. So an equation, speed is shown as speed is given by small letter v equals the distance covered over time, where v is the speed, d is the distance covered, and t equals time of travel. So using this, let's have this one. Example 1. Elma Moros, the fastest female sprinter in Southeast Asia, can run a 200-meter distance course in 24.42 seconds. What is Elma's speed? First, we must know the given. Okay, the given is the distance, which is 200 meters. And the time, given by the word seconds, it is t equals 24.42 s. And you are asked to find Elma's speed, given by the symbol v. And using the formula a while ago, v is equal to d over t, and by substitution we have V equals, this is 200. Okay, 200 over 24.42. So we can reduce it by 2. So divide 200 by 2, 24.42 by 2, we have 10.49. So you can also use 200 meter over 24.42. So we arrive with the same answer. Okay, the speed of Elma is equal to 9.53 meter per second. So very easy to follow. Let's move on with the next one. What is velocity? Sometimes describing the speed of the object requires direction. Velocity describes the speed and direction of an object. Velocity, like speed, has SI units of meters per second or m per s, kilometers per hour or km per h, or miles per hour or mph. But because it is a vector, the direction of the motion is included. Like speed, you can describe either the average velocity over a time period or the velocity at a specific moment or instantaneous velocity. Okay, average velocity is displacement divided by the time which displacement occurs. Okay, so this is the formula. So V is equal to d over the time interval. So velocity talks about the displacement. Okay, V is velocity, d is displacement, t sub t is time interval. So let's proceed with example 2. Laymar drove to the city to pick up a friend. She went 3,000 kilometers east in about 10 hours. So let's calculate her velocity given the distance, given the displacement. It is 3,000 kilometers east and the given time is 10 hours. And you were asked to find the velocity. So for the equation, we have the velocity average is equal to d over the time interval. So V average is equal to t over t interval. So by substitution, we have V average, or this velocity, is equal to 3,000 kilometer due east over 10 hour. So by simplifying this, we have the velocity average is equal to 300 kilometer per hour due east. So remember, speed is just a magnitude. When we say velocity, there is a magnitude and direction. Let's talk about the constant speed versus instantaneous speed. In the earlier example, Laymar drove at an average speed of 300 km per hour. In her course of driving, it is possible that Laymar's speeds varied. There may be times that she increased or decreased her speed at certain points in her travel. However, it is also possible that Laymar was neither speeding up nor slowing down. Her driving speed would be the same the entire trip. If the car or any object was moving over equal distances in equal periods of time, it would have a constant speed. It is usually difficult to maintain a constant speed, particularly in driving. The speed at any instant is called instantaneous speed. Similarly, the velocity of the moving object is called the instantaneous velocity. The easy way to determine the speed at any moment in a moving vehicle is through the speedometer. Take a look at the dashboard of the car or a jeep when you ride in one of them. The circular gauge as shown in figure 1, is called the speedometer here. A speedometer is an instrument that determines the instantaneous speed of vehicle. Thus, the speedometer always registers the same speed. At the red light, the car has 0 km/h speed, and along the highway, its speed is probably 80 km/h. Speedometers are important to the drivers because they need to know how fast they are going so they know if they are already driving beyond the speed limit or not. So very important, speedometer. Let's talk about speed limit. Speed limit is either a maximum or minimum speed allowed for vehicles. The maximum speed limit in school zones is usually 20 km/h, but in highways, vehicles are required to run at a minimum speed of 60 km/h. Drivers are required to observe the speed limit for the safety of passengers and pedestrians. Motion with constant velocity is very rare. In our daily trip to school, the traffic signals, the stoplights, the turns, the bumps, and the pedestrian crossing the street makes us change velocities. The vehicle we are in speeds up, slows down, or changes directions. In addition, on a roller coaster ride, passengers experience rapid changes in velocity. What type of motion do these objects exhibit? What other measurement do you need to describe these types of motion? So let's talk about acceleration. We are done with the speed and the velocity. What do we mean by acceleration? Drivers can change the speed and direction of the car depending on the need. They can step on the gas pedal to increase the speed of the car. At times, they push on the brake pedal to slow down or come to a stop. They can also turn the steering wheel to change the directions of the car's motion. You need two quantities to calculate velocity, speed, and direction. Changing either of these quantities about changes the velocity of the object. Another quantity to describe a change of motion is how much time elapsed while the change was taking place, and this is called acceleration. Acceleration tells how fast an object or a body changes its velocity. An object is accelerating when, first, it is traveling in one direction with changing speed, either speeding up or slowing down. 2. Moving at a constant speed but changes its direction. 3. When it changes both the speed and its direction. In other words, acceleration is the rate of change in velocity. And when we say slowing down, this is called deceleration. The SI unit of acceleration is meters per second, or meter per s, or it can be mathematically simplified to meters per second squared, or m per s squared. But other units of acceleration such as kilometers per hour, this could be km per hour, or km per h squared, and miles per hour, again mile per hour, or mile per h squared, are sometimes used. Again, this is for acceleration. So, as an equation, acceleration is shown as acceleration A equals bf minus vi all over t, where your A here is the acceleration, your v sub f is the final velocity, and the v sub I is the initial velocity, and the time here is the time of travel. So there is the initial, the starting, final is the end point. So let's examine the figure below showing the velocity of the car changing. So figure 2, the car moved from rest to 25 km/h in 5 seconds. What was the acceleration of the car? So the diagram shows the velocity of the car was 0 km/h at the start. That will be your initial velocity. At the end of 1 second, the velocity was 5 km per hour. At the end of 2 seconds, it was 10 km per hour. At the end of 3 seconds, 15 km per hour. And at the end of 4 seconds, 20 km per hour. And at the end of 5 seconds, the total time elapsed. The velocity was 25 km per hour. And that will be your final velocity. In this case, the car's speed is increasing an average of 5 km per hour in each second. So using the formula a while ago that A is equal to B sub F minus B sub I all over T. By substitution, we have 25 km per hour minus 0 km per hour all over 5s. So 25 minus 0 is same 25. Then when we simplify this by simple manipulation by division, so we have 5 km per hour per second. Okay, remember that. What's more, let's have this activity 3. It is accelerating or not. Directions, study the diagram. Directions, study the diagram below and answer the questions that follow. Diagram A, a rolling ball. So as you can see, there is a 0 second, 1 second, 2 seconds, 3 seconds, 4 seconds. And the velocity is v sub 1 up to v sub 4. Is the ball accelerating? Why or why not? Yes, because there is a change in speed with respect to time. Let's have diagram B, a jeepney traveling along mountainside. So, let's have this guide questions. Describe the direction of the car's motion in diagram B. Car moves in a zigzag motion. Is the car accelerating? Why or why not? Yes, it's accelerating. There is a change in position from one place to another with respect to time. Let's have diagram C, a car traveling around the oval. Guide questions number 8. Is the car changing its direction as it travels around the oval? There is a change in direction as the speed is constant but velocity is not. Number 9. Is the car accelerating? Why or why not? It is accelerating because the direction of the velocity vector is changing. And number 10. Based on the 3 diagrams, what are the conditions that should be present to say that an object is accelerating? All of them, they are in different scenarios, but they are showing acceleration. What's more, let's have this activity 4. It's time for us to solve this problem. Directions, solve the following problems below involving speed and velocity. Show your solutions. Let's have number 1. A bird can fly a distance of 250 miles in 5 hours. What is the average speed of the bird? Let's have the solution. Given the distance is 250 miles and the time given is 5 hours. And the formula that we're going to use is V equals D over T. And by substitution, we can have 250 miles over 5 hours. By division, we have 50 mile per hour or 50 miles per hour. Okay, let's have number 2. If you travel 300 kilometers in 6 hours, what is your average speed? Let's have the given. Distance is 300 kilometers. The time is 6 hours. And the formula is V equals D over T. And by substitution, we have 300 kilometers divided by 6 hours. So we have 50 kilometers per hour. So very good. Okay. Let's have number 3. A jeepney moves along the straight road at an average speed of 10 meters per second. What is the distance traveled by the jeepney in 2.5 seconds? Okay, so given speed is 10 meters per second, the time is 2.5 hours. We need to change hours into second. So we have 2.5 hours times 60 minutes over 1 hour times 60 seconds per minute. To simplify further, we arrive with 9,000 seconds. And the formula we're going to use is d equals v times t, where d is 90,000 meters. Okay? So that will be your answer. How do we do that? So we have d equals 10 meter per second times 9,000 seconds. So we arrive with the distance 90,000 meters. Very good. So you can follow with our discussion. So for this, congratulations. So what I have learned. So we need to answer this. What is speed? It is the rate at which an object changes its location. How will you differentiate speed from velocity? Speed is the time rate at which an object is moving along a path, while velocity is the rate and direction of an object's movement. At a constant distance, how is speed related to the time of travel? If an object travels at a constant distance, speed will be inversely proportional to the time elapsed. This situation means that as the speed increases, the time that has elapsed will be shorter. Number 14. At a constant time of travel, how is speed related to the distance traveled? Speed is directly related to the distance traveled. When one variable increases, the other increases as well, and vice versa. Number 15. Who is traveling faster? A person who covered 10 meters in 5 seconds, or the one who took 10 seconds to cover 20 meters? Both have the same average speed, so neither is the fastest. Number 16. When can we say that an object is accelerating? An object is accelerating if it is changing its velocity. Very well said. Let's move on. What can I do? So, this is for your second assignment. Congratulations, you have done a great job to apply what you have learned in this module to the next activity. So please include this as your second assignment. So let's have the assessment. Direction. Choose the best answer from the given choices. Key in your answers in our class point up. Okay. Which of the following instruments is best used for measuring the time of moving object? A. Is it stopwatch? B. Wristwatch? C. Alarm clock? D. Digital clock? Correct. That is letter A. Stopwatch. Number 2. Jay wants to measure the speed of his motorcycle. What instrument will he use? A. Ammeter. B. Barometer. C. Speedometer. Or D. Voltmeter. Correct. Very good. That is C. Speedometer. Which of the following is an example of velocity? Is it A. 30 seconds, B. 30 meter per second, C. 30 meters east, or D. 30 meter per second east? Very well said. That is letter D. 30 meter per second east. Number 4. Which of the following is the formula used for solving speed? A. V is distance times time. V is V equals distance over time. C. V is equal to time over the distance. Or D. V is equal to D, or the distance, over time over time. Very good. That is letter B. V is equal to distance over time. Number 5 question. Which of the following is defined as the distance covered per unit time? Is it A. Acceleration, B. Displacement, C. Speed, D. Velocity? Correct. That is letter C. Speed. Number 6 question. Which of the following is not a unit of speed? A. kph, B. miles per hour, C. meter per second, D. meter per second per second? Correct. That is letter D. Meter per second per second. 7. What is shown when you look at the speedometer in a moving car? A. Average speed, B. Average acceleration, C. Instantaneous speed, or D. Instantaneous acceleration? Very well said. That's correct. It's letter C. Instantaneous speed. Let's move on with question number 8. Which of the following is defined as a speed with direction? Is it A. Acceleration, B. Distance, C. Displacement, D. Velocity? Correct. Very good. That is velocity. Letter D. Number 9. Which of the following shows that an object is accelerating? A. A cart moving at 5 km per hour. B. A car changes. B. A car changes velocity 5 km per hour in every second. C. A cyclist moving with a constant speed of 6 km per hour. Or D. A car is moving at 10 km per hour going west along the highway. Very good. And that is letter B. A car changes velocity 5 km per hour in every second. Number 10 question. Which of the following statement or statements is or are true? So let's look at the right side. The data below are obtained from 500-meter dash competition final in the Olympics. So you're given athletes: Philippines, Japan, Nigeria, USA, China, United Kingdom, and Ghana. And for the recorded time in seconds, Philippines is 57.3, Japan is 59.6, Nigeria is 54.3, USA is 57.4, China is 59.7, United Kingdom is 58.6, and Ghana is 55.3. So, number 1, Philippines athlete beat Japan. 2, an Asian beats a European in the finals. Or 3, Africans are the fastest runners in the finals. Is it A, 1, 2, and 3? B, 1 and 2 only? C, 1 and 3 only? D, 2 and 3 only? Correct. Letter A, 1, 2, and 3. Philippines athletes beat Japan. An Asian beats a European in finals. Africans are the fastest runners in the final. Number 11. A cyclist drives along the straight highway for 25 hours with a displacement of 100 km south. What is the cyclist's average velocity? A, 0.4 km per hour north. B, 0.4 km per hour south. C, 4 km per hour north. Or D, 4 km per hour south. Very good. That is letter D. 4 km per hour south. Number 12. Refer to the table below. What is the speed of runner Z? Runners W, X, Y, Z, distances in meters 70, 80, 95, 105 respectively, and the time are the same, 10, 10, 10, 10. Is it A, 0.10 meter per second, B, 1.05 meter per second, C, 10.5 meter per second, or D, it's 1050 meter per second? Correct. It's letter C. It is 10.5 meter per second. Number 13. Based on the table below, what will be the speed of the moving object in 2 seconds? Speed meter in second. Time is distance m. Okay, 0, 0, 0, 5, 1, 5, 2, 10. Okay, what would be the value of the question mark in the given table? Is it A, 2, B, 3, 4 for C, and 5 for D? Okay, so that is 5, letter D. Very good. Second to the last question. Michelle Ann conducted an experiment on speed using her toy car. She listed all the data she gathered in a table below. Upon analyzing her data, she concluded that toy car C is the slowest among the 4. Do you think her conclusion is correct? Toy car A, with a distance of 100 and the time in second is 10. Toy car B, with a distance of 100 centimeters with the time second 15. Toy car C, with a distance of 100 and the time in second is 20. Or D, distance in 100 centimeters with the time in S is 18. A, yes, because its speed is 20 meters per second. B, yes, because it has the greatest time recorded. C, no, because all the toy car traveled the same distance. D, no, because the slowest toy car is the one that took the least time. Yes, you are correct. It's letter B. Yes, because it has the greatest time recorded. Let's have the last question. Marlo was asked by her teacher how to solve the speed of any object. She said that to solve for the speed of an object, one must multiply the distance traveled by the recorded time of travel. Do you think her process is correct? A. Yes, because multiplication is the way to solve for speed. B. Yes, because she had all the needed data like distance and time. C. No, because in solving for speed, one must divide the distance traveled by the recorded time of travel. Or D. No, because in solving for speed, one must add the recorded time and the distance traveled. Congratulations, you got it right. That is letter C. No, because in solving for speed, one must divide the distance traveled by the recorded time of travel. So we are done with our assessment. So let's proceed. This is the additional activities. So you're going to graph the given velocities and time interval as shown. Label your graph correctly. Place the velocity on the y and x axis. Connect the points after graphing. Then compute and analyze the acceleration of the object between point A to C, point C to D, and point D to E. So here is the table. Okay, so with this, if there is no question with the topic, this is our topper saying thank you and good morning.